Hello Year 11 and welcome to the third video for our third topic. We are looking at linear modelling here. Linear modelling, modelling in mathematics, so we're not real good looking people. Modelling in mathematics is where we try to use some mathematical system to replicate some natural sort of a system. Okay, we assign numbers to things to try to come up with a way of predicting what might happen in a real life situation. Yeah, that's the idea. It's very much about application. Anyhow, I think that's all we need to talk about before we jump straight into an example. Here we go. Brett's organising a 21st birthday party. Name doesn't begin with M. What's going on there? Brett's organising a 21st birthday party. Total cost of the party. You can read all that stuff. Pause if you need to. But I have a table of values here which relates N to C. Which one's independent? Top row, which would normally be X, right? Our input is the number of guests, N. So this is a bit like X, remember? And this is a little bit like Y as a reminder of how we've been doing these things. Okay, and that makes sense. The cost of my party depends on the number of guests. Not so much the number of guests depends on the cost of my party. That's not usually how this would be worked out. So, which one is the dependent? Dependent means the bottom row, C, the cost. Right, it depends on the number of guests. Right, it will be on the vertical axis. It's my output from some sort of function, hopefully. Find the gradient of the linear relationship between N and C. Now, these are not increasing by 1, more the pity, because then we could have just read off the difference in the bottom row. No, I'm going to have to use my gradient formula, which you might remember from last time. I like using numbers like this. I'm going to use these ones here, I think. I'm going to say that M equals y2 minus y1. So 2,000 minus 1,720 divided by x2 minus x1, 120 minus 100. Therefore, M equals, right, what have I got here? 280 over 20 is 28 over 2 equals 14. There we go. M equals 14. Find the vertical intercept. Well, I could graph this and draw it as neatly as I can and try to read off where my line crosses the vertical axis, which is going to be the party cost. But that's not going to work very well. So watch this for a technique. I'm going to use my gradient intercept form and I'm going to substitute values into it. Right? I'm going to say that, let's go with this one here. I'm going to use this as X and Y. And I'm going to say that Y, or 1720, equals MX, that's 14 times 100. Right? There's my MX, plus my Y-intercept, which is C. Not a big C, it's a little c, confusing. C for confusing indeed. So, therefore, I'm going to say that, well, if we try a fair bit of working, 1720 equals 1,400 plus C. Therefore, C equals 1720 minus 1,400 equals 320. Okay, that's the y-intercept, 320. If N came down to 0, C would be equal to 320. Right, the linear function for C in terms of N, that means that it's got to be C equals something. Right, just the same as it's Y equals something else. So C equals 14N plus 320. Isn't that easy once we've done all the other work? If it was graphed, which variable would be showed on the horizontal axis? Horizontal, right, goes across, looks like a cross, would be the X, which is my independent variable. In this case, it is N, the number of guests. That's my answer. N goes across. What does the vertical intercept of this function represent? Well, you could say it's where the line crosses the vertical axis, but no, that's not really answering the question. What does it represent? Well, in the context of this birthday party, it tells me how much it costs if I have no guests. Right? It's sort of like a base cost or a setup cost or an initial cost. But typically the answer that markers seem to like here is the cost for no guests. 0, I like to use the cost for 0 guests. I might say, i.e. a setup cost. Right, I think that works out. Find the cost of the party if there were 94 guests. Well, I just put n equals 94, that's my input, and my output is going to be the cost of the party. So I'm going to say that my cost is equal to, here's my formula, 14 times 94 plus 320. There's my formula, there's my substitution. I need to evaluate this. Am I going to do that in my head? No, indeed I'm not. I'm going to pause and get my calculator. Ready? Here it is. Here's my calculator. Should look just like yours. 14 times 94 right, plus the, why did I say 30? It should be 320. Right, fix that little typo up. Oh, I'm going to have to find that calculator again. Plus 320. Come back, calculator. Here it is. 14 times 94 plus 320. Before I press equals, I'm going to use a little bit of common sense here. I'm going to say I expect my answer is going to be somewhere, I've got between 80 and 100 guests, so somewhere between 1440 and 1720. I think it's going to be about 1680 or something like that. Okay? Somewhere in the 1600s. Ooh, 1636. Right, $1,636 is how much it will cost for 94 guests. Always good to have a bit of an idea, using some common sense, a bit of an idea before you arrive at your answer. Well, there we go. That is linear modelling. You have to read carefully, determine your dependent and independent variable, calculate the gradient and y-intercept, and thus arrive at some sort of formula, an equation relating those things, ideally in gradient intercept form, that is y equals mx plus c. Write it like that, and from there, you can interpret that. You can apply that to calculate other things, as we did here, to work out. Right, we can know from my table how much it would cost for 94 guests. We could bracket it in between these numbers, that's true. But we arrived at an equation to describe the situation, and we then substituted into that equation to anticipate a result. Rightio, that's it. Hope you enjoy. I will see you in class.